Welcome to Recursive Methods. In this lecture, we'll start off by understanding exactly what recursion is. Then we're going to look at the properties of recursive methods. We'll be looking at the practical uses of recursion, and then we'll be comparing recursion with iteration. So let's start off by understanding what is recursion. And basically what recursion is it's a method that calls itself. It's kind of like a loop, and it's often referred to as a method within a method. And the best way to understand it is, let's say we have this eat food method within any class, doesn't matter what it is. Now within this eat food method, part of all the lines of code, we have eat food. Now basically what we're doing is within the eat food method, we're calling the eat food method. So kind of when we would run this eat food method, part of the execution would be the eat food method we run. So this is basically an example of recursion, because the eat food method is calling itself. And technically this would run infinitely, because every time you said eat food, the eat food method would keep running itself, and this would go on infinitely. But that's basically what recursion is. Recursion is a method that calls itself. So there are some specific properties of recursive methods, and the first thing is there's a base case for termination. So as we saw earlier, when we would keep using that eat food method and keep running it, it would go infinitely. But in order to terminate or end the program, there's often a base case. And there's a non-base case that gets closer to the base case. So every time a recursive method is run, every time it reruns the method or recalls the same method, we want to get closer and closer to the base case, so eventually it'll stop. And this is basically, recursion is used in order to simplify code. It's kind of like logic, and you want to use this logic in order to make your life as a programmer easier and do something more simply. And it's important to avoid recursion for large sets, because although recursion is a helpful tool, with large sets it does not work very well. And this base case and non-base case, these are kind of things that we've seen with loops as well. But as we look at an example of recursion later in the lecture, you'll get a better understanding of exactly how these base case and non-base cases work. So some practical uses for recursion are the Fibonacci series, which is 0, 1, 2, 3, 5, and so on. And basically what happens is 0 plus 1, the first two numbers, equals the third number. The second and the third number equal the fourth number. The third number and the fourth number added together, the fifth number, and so on. So 0 plus 1 equals 1, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, and so on. And then we have something called factorials, which are things like 3 exclamation mark, which is equal to 3 times 2 times 1. And then we also have patterns like 3 asterisks, 2 asterisks, 1 asterisk, so things like that. So that's where recursion really fits in. And now let's finish off by comparing recursion with iteration. So both of them have repetition. Now with recursion we have we have method calls, where basically we're calling the same method within a method. While with iteration we have a statement like a for loop or a while loop. And there's often a base case or a termination test. So that occurs both with recursion and iteration. With iteration, we know with the while loop we check for a condition, and similarly for the for loop we'll say if I is less than x or something, anything like that. And both can occur infinitely, and usually iteration is preferred over recursion because it takes up less memory. But again, if recursion can simplify the code more than iteration, that's when you want to use recursion. But usually iteration has the upper hand over recursion. So now let's move straight to Dr. Java and look at two quick examples of recursion in the use, so you can see how it's used in a program. So here we are in Dr. Java, and I'm looking at the recursion test.java file. And this just has a class recursion test, and it contains two methods, test and test2. And these two methods display recursive methods, and we'll just understand how recursive methods work, what the logic is behind them, and then see the output of them. So here we are, we have the public class recursion test. We have a main method, which we're going to skip by for now. And we're going to move to this first method, public static void test int n. So what this is doing over here is it's not gonna return anything. It's a static method, which means that we can call it in our main method, and it's gonna return it. It takes in an integer of n, and its name is test. So what this is doing is saying if n is greater than 0, which is our base case, then the system is going to print out n, and then we're gonna say test n minus 1. So there's a lot of things going on over here. So first we're saying is n greater than 0, and this is what is known as our base case. So if n is greater than 0, which is basically our base case, we're gonna print out n, and then we're gonna go test n minus 1. Now please remember that we are in the test method itself, and then we're going test n minus 1. So basically what we're doing is we're calling the same test method within the test method, and that's a perfect example of recursion. So what happens is this n minus 1 is the non-base case, because as we decrease n's value by 1, it'll slowly start getting closer and closer to 0 if it's not already there. So it'll keep getting closer and closer to 0 as we go n minus 1 every time. So here in the comments, let's take a look at exactly how this program would work. So let's say we test 3, so n is equal to 3. So what happened is the computer would check, is 3 greater than 0, which comes out to be true, so the base case is passed. The computer would print out 3, as we can see over here, and then we would say test n minus 1, or test 3 minus 1, which is test 2. So then what would happen is after these two steps are completed, we would have test 2. And when we're running the test with n equals 2, we'd say is 2 greater than 0, which is our base case, and that would evaluate to be true. So then the system would print out 2, which we have over here, print out 2, and then it would say test n minus 1. So now this time our n is 2, so 2 minus 1 equals 1, so now we'd be going test 1. Now when we're going test 1, n is equal to 1, and then we're saying is n greater than 0, and that is true, so our base case is true. And then what we're going to do is we're going to print out 1, and then we're going to say test n minus 1. Again, this time our n is equal to 1. So 1 minus 1 is equal to 0, and hence we would be saying test 0. So now we go back over here and we say test 0. So if n is greater than 0, 0 is not greater than 0, so the base case is not passed, so this code is not executed. So that's what happens. So what happens is now at the output we have 3, 2, and 1 printed out, and all we had to do is say test 3, and that's it. After that, so what all we did was we said test 3, and all that happened after this is what happens when you use recursion. Everything else was basically a product of just doing this, and we had 3, 2, and 1 printed out on separate lines, and that's what we want. So now we saw a couple of things with this method. We saw a base case, which is n is greater than 0. And we saw a non-base case, which is n minus 1, because as we decreased n's value by 1, we started getting closer and closer to 0, which was our base case. And this is recursion because we're calling the test method inside of the test method itself. So that's an example of recursion. Now let's look at our final example that we'll be taking a look at of recursion, and this is a method test2. So again, public static void test2 takes in an integer n. So again, it has a similar base case if n is greater than 0. And what it does here is it says this also has a for loop inside of it. So it says for int I equals 1, I is less than or equal to n, I plus plus. So basically it's saying that I is 1 and I has to be less than whatever n is, less than or equal to n is, and it's going to increase by 1 every time we run this loop. The system will output this asterisk, and it's going to keep outputting this asterisk until I is not less than or equal to n. And then once I is greater than n, then this for loop will stop terminating and the rest of the code will be executed. And then we'll start printing on a new line, and we'll say test2 n minus 1. So the best way to understand this is to basically run, basically think of what would happen if we said test2 3. Let's say we ran test2 3. So what happened is that our n is equal to 3. So it would say is n greater than 0, which is our base case. So as we know that 3 is greater than 0, so this would be fine. Now what we would do is we would execute this for loop. So for int I equals 1, I is less than or equal to n or 3, I plus plus. So what happens is I is equal to 1, 1 is less than 3. Okay, so what happens is an asterisk is printed out once. Then the value of I increases by 1. So the value of I is now 2. 2 is less than or equal to 3. That's true. So an asterisk is printed out again. I's value increases once more, and now I's value is 3. 3 is less than or equal to 3. That is true again. So this asterisk is printed out once more. And then I increases by 1 more. So now I is 4. 4 is less than or equal to 3. This evaluates to be false. And now this after printing out 3 asterisks, this method stops this loop stops running for that moment. Then we go to the next line, which is system.out.println, and this basically ensures that the printing will start on the new line. The next row of asterisks will start on the new line. And then we go test2 n minus 1. So what's happening now is we're calling the test2 method within the test2 method, and n minus 1 is our base case, just like we saw in our last example. And now we're going to be running test2 using the number 2, and n will be equal to 2. So again, let's do it again. So we have n is greater than 0, 2 is greater than 0. That's true, so we pass our base case. Now int I is equal to 1. 1 is less than, or I is less than or equal to 2. So in this case, for right now, I is 1. So we say I is less than or equal to 2. So we print out 1 asterisk. Then I's value increases by 1, and now I has a value of 2. Then we say 2 is less than or equal to 2. That comes out to be true. So we print out the asterisk once more. And now I's value again increases by 1. And now I's value is 3. Now we say 3 is less than or equal to 2. And that comes out to be false. So now we stop running this loop and we go again. Now we've printed out 2 asterisks. So up till now what we have is we have one row with 3 asterisks, then we have another row with 2 asterisks. And what we do now is we run system.out.println to start printing on a new line. And then over here we say test2 n minus 1. Now n is 2 right now, so 2 minus 1 is 1. So we're going to be saying test2 1. So again we start from the beginning, test2 1. So n is 1 now, so is 1 greater than 0? That is true. So our base case is executed. And now is fine, or is true. And now we're going to run this for loop again. Int I is equal to 1, and I is less than or equal to 1. So 1, which is right now I's value, is less than or equal to 1 is true. So 1 asterisk is printed out on a new row. Then we say I plus plus, so I's value increases by 1, and now I's value is 2. 2 is less than or equal to n, or 1. 2 is not less than or equal to n, so now this for loop stops executing, and now what we have is we have 3 rows, the first row with 3 asterisks on it, the second row with 2 asterisks on it, and the last row with 1 asterisk on it. Then what we do is we say system.out.println, so whatever printing will happen will start on a new row, and we say test2 n minus 1. And remember, our n is 1 in this case, so we'll say 1 minus 1 is 0, so test2 0. So now when we are running test2 0, we're back here again at the beginning, and we have n is equal to 0 this time. So we say if n is greater than 0, if 0 is greater than 0. And we know that now that evaluates to be false. And because that evaluates to be false, we know that because 0 is not greater than 0, which is our base case, we finally terminated our recursion. And what's happening now is this is done running. So test2 0 is done right after this, because there's no code after this if loop, and everything is over. That's it. So that's how we terminate our program, and that's exactly what happens now. So now what we've done is we've had a base case, which is n is greater than 0. We've had a non-base case, which takes us closer to our base case, which is n minus 1. And we've used recursion because we're calling the test2 method within the test2 method itself. So now what I have here is test3 and then test2 3. So these, we're calling both methods, and we're saying that we want to print out 3, 2, 1, and we want to print out 3 asterisks, 2 asterisks, 1 asterisks. So let's compile and run to make sure everything is working. So here we compile and here we run. And as you can see, we get our output. So we get 3, 2, 1, and we get 3, 2, 1. 3 asterisks, 2 asterisks, 1 asterisk. Again, I could replace 3 and 3 with whatever numbers I'd like, and that number of asterisks would be printed out, or that countdown would happen, whatever I would like. And that's the great thing about recursion. It's very flexible. You're using logic, and you're calling a method within a method in order to make your life easier. So now this program becomes a lot simpler by doing this. I understand that you could do this by iteration, but this also simplifies it, and it's a good way to demonstrate recursion. So to recap, with recursion, what you're doing is you're calling a method within a method, and you have things like a base case, a non-base case, and overall recursion is a very important logical part of computer science.